your homework for today was to prepare Module 3.2. But before we get into Module 3.2, it's a long one.
Yeah.
And I feel like what we need to do is review what was learned yesterday, okay? Let's start with the production function. I want you guys to rapid fire tell me everything you remember about the production function. Ready? Go. Just call it out.
Increases at a decreasing rate.
Increases at a decreasing rate, yes. What is the production function? What does it show us?
The relationship between the inputs and the outputs.
Okay, it does demonstrate a relationship between the inputs to production and the outputs to production. Which specific type of inputs, Parker? Labor, yes. The production function on the horizontal axis should always be a variable input, something that can vary, right, with the output, and labor is the number one variable input. What does the production function look like? How's it shaped? I'm seeing a lot of hand motions. Let's say it out loud. What does it look like? It kind of is like goes up and then it flattens out and then it can come down, right? When you said that it shows input versus output and it is increasing at a decreasing rate, what is that describing? What is it telling us about that input into the production of a good? Yeah.
It shows the diminishing return. The marginal product of labor is diminishing.
Okay, you guys remember quite a lot. That's really, really good, okay? So, to just a review, you're not gonna see a lot of questions and probably zero questions on the micro exam about the total product curve, okay? But in terms of what from yesterday you will need to remember, the most important is the formula for the marginal product of labor, okay? The marginal product of labor is something you're gonna see again and again and again. And the thing about that formula is that it shows us what Christina was just saying about there being diminishing returns to a variable input, okay? It shows us that even though the total is increasing, it's increasing at a diminishing rate. Again, that's the too many cooks in the kitchen situation. Do you guys feel okay about going forward? All right, I'm gonna put a structured break in the middle of these notes because it's a lot and I'm gonna be talking for way too long and you guys are gonna need a mental break to spend a little bit of time reviewing what you just did before we can move on, okay? This all is a lot in terms of objectives and a lot of the kind of information we're gonna go over. And remember how I said at the beginning, there was gonna be a lot of graphs? One of the things I want you guys to practice doing at our break, hopefully you'll get there in time, is drawing some of the different cost graphs that we're gonna look at today, okay? So I'm gonna have you guys all, when we do the break, go get one of the dry erase things and start practicing drawing those graphs. You're gonna draw a lot, okay? All right, so let's get started then with the notes for today. We're gonna define and calculate the various types of costs that firm face in the short run. This is really important. We're just doing the short run right now, where we're assuming that at least one input is what? Fixed, exactly, right? We're gonna have like one piece of equipment, one size of the plant or the office space or whatever is fixed. We're gonna explain how a production function with diminishing marginal returns yields an upward sloping marginal cost curve. Our marginal cost curve is gonna look like a Nike swoosh. You're gonna see what I'm talking about in just a second. And we're going to look at a graph that shows the relationship among the different cost curves. And we're gonna talk about why the cost curves look the way that they do. And use graphs to illustrate shifts in fixed and variable cost curves. Okay, so there's a lot of cost curves. We're gonna have, at the end of today, 4 cost curves, okay? All right. Yesterday, you guys learned what a fixed cost is versus a variable cost. This was the definition, these were the definitions that I was speaking to yesterday. The ones that I thought that they had, the definitions that we had in our presentation yesterday, I didn't think were the greatest. But these are the ones that I was more looking for, right? Fixed cost does not depend on the quantity of output. The variable costs do, right? So as you add more workers, you get more output. As you add more electricity, you get more output. But you don't get any extra output by paying your insurance payment every month. You just have to pay it. It's a fixed cost, regardless of how much output you make, okay? And then if we take fixed costs and add them to the variable costs, that will give a firm their total costs, okay? So we haven't even gotten into explicit versus implicit costs yet for firms' cost curves. But one thing that you should assume is that these do include both explicit and implicit costs for now, okay? We'll break it apart at a further time. Does that make sense? Okay, so fixed costs plus variable costs give a firm their total costs, okay? Fixed costs, again, things that you have to pay regardless of how much output. Variable, vary with that, the amount of output. Take those two together, that gives a firm its total costs. Okay, there it is, right in front of you. It's expressed mathematically in that way. So TC is going to be total cost, FC fixed costs, VC variable costs. It's pretty simple. And when we get to our total cost curve, we're going to show how total cost depends on the amount of output. I want to say something as well about total cost curve here. You're only going to see this really once, and then it's going to go away, okay? So this is for illustrative purposes only. It's not going to be one of the cost curves that you need to worry about memorizing and being able to draw. It just is a way to demonstrate to you that as a firm produces more output, their total costs increase. The primary reason for that is that as they produce more, they're adding more and more variable costs, more labor, more raw materials, more things like electricity and stuff that vary with the amount of output that is produced. Okay. Yeah, the labeled points just correspond to the rows on the table. That's just the cost curve schedule. All right, and I want you guys to focus on this part though, because it does say the main reason the total cost curve is upward sloping is because of labor, okay? Labor is the most important and expensive variable cost that any firm is going to have to pay for. It also steepens, like once you get to like point C, it starts to go sharply up. And that is because there are diminishing returns to labor, okay? Diminishing returns to labor. As you add more workers, you get more and more output, but the amount each one adds becomes smaller and smaller. So that costs you more, right? Okay. All right, let's talk about marginal cost. Marginal cost. It's one of the most important things that we are going to derive. It's the change in the total cost caused by producing an additional unit of output. So it's equal to the change in total costs divided by the change in output. That's what Q is in the denominator, okay? it says here that marginal cost is equal to the slope of the total cost curve. So it is also upward sloping. It looks a little bit different, okay? But again, here's the formula for it, which I had already put on the board. And we can look at, like, if this is a firm's cost schedule, we've got, here's the quantity of output, here's the fixed cost, here's the variable cost, add those two together, that gives you total cost, and then marginal cost is how much total cost changes as you produce additional units of output. Now, I'm gonna give you guys a really important tip. When you are calculating marginal costs, because you will have to do this, you need to pay attention to the quantity change. A lot of times, it's gonna just go up by units of one. And so all you really need to worry about for marginal cost is the change in total cost, because it's always going to be increasing by just one unit of output in the denominator. And so when that's true, right, it's just that over one is that number, right? But there are frequently questions on my test and on the exam that are gonna switch this up, right? And they are going to have units of quantities that are different than going up just by one. So don't make the mistake of forgetting that the marginal cost formula includes the change in output in the denominator, okay? Be attentive to that, because it's a way for the College Board and for me to test, do you really know the formula? And can you accurately calculate the change in total cost, like in what's happening with marginal cost, okay? So just pay attention to that. I'm gonna give you another pro tip of evaluating questions that could be in the workbook, could be on a test, something or a quiz, something like that. When these boxes aren't all filled out, and you need to fill them out, okay? Fixed cost, as you can see, always the same, because fixed costs don't change given how much output you're producing. If one of these is blank, if some of these are blank and you have to fill it in, one of the tricks to figuring out what is this firm's fixed cost is to look at total cost when there is zero output. Because at zero output, there will not be any variable costs. So at zero output, fixed cost and total costs are equivalent, okay? They're equivalent. Is all of this making sense to you guys so far? Great, perfect. And then, you know, the other parts of that, of this schedule might be like, okay, they'll leave certain things blank and you've got to figure it out. You can figure, like, you just have to solve for X, right? If they give you total cost but not the variable cost, and you've already figured out what the fixed cost is, it's just total cost equals whatever your fixed costs are plus X, right? And you just solve for X. Does that make sense to you guys? Okay. Because those are things that come up all the time on assessments. Okay. I already went through that. Variable cost in the column 4 shows total cost. Okay. And then marginal cost. Again, you're looking at the change in total cost divided by the change in output. Luckily, in this example, it's only increasing by 1 unit at a time. And so there you go. Okay. This is a total cost curve. This is the marginal cost. Now, when we get to looking at marginal cost curves, they are gonna look more like this. Like I said, the Nike swoosh, it doesn't show it in this particular graphic, okay? And that's because at however many workers this is, they're specializing still, okay? So as you add workers and they're specializing, like you guys did with making pizzas the other day, they're getting better, more efficient, more productive as you add workers. But then the too many cooks in the kitchen stuff comes into play, and then our marginal costs start going up with diminishing returns to labor and adding what it costs to pay all those additional workers. Does that make sense to you guys? Okay. All right. So
So the marginal cost curve is not a straight line, it's
Yeah.
that one?
now this is they're doing this to illustrate the point that marginal costs are increasing as you increase production quantities, okay? But when we get into a more realistic marginal cost curve, it's gonna look like this. And the reason why is because of that worker specialization. Okay. Again, it slopes upward, reflecting diminishing returns to the variable input. Okay. Another cost, okay, so far we've got marginal costs. That's number one for our cost curves for a firm, that you guys are gonna need to know how to draw it, know what it means, all that kind of stuff, okay? The next cost curve with which you need to become intimately familiar is the average total cost curve. The average total cost curve. This has a very different formula. Average total cost is equal to total cost divided by quantity at that point, okay? So instead of looking at the incremental increase of total cost at each point along the way, you're just basically saying, here's the total cost, we're dividing that by the amount of output, and that gives you the average across the board, along all the amounts of different quantities of output, okay? I want to be really clear about something in the relationship between marginal costs and average total costs, okay? The marginal, when it's coming down here during specialization of workers, it's pulling the average down. And then as marginal costs increase, the marginal is pulling the average back up, okay? So the marginal cost curve is gonna look a little bit more severe. And then in a second, we're gonna look at how the average total cost curve looks more like a bowl kind of shape. All right. So here, if we were trying to calculate Selena's Gourmet Salsa's average total cost, here you just take total cost and you would divide it by the number of quantity of output. In this case, I think it's cases of salsa, right? So it's just 216. If you wanted to find out what her average costs were if she produced 3 cases of salsa, it's just 216 divided by 3, right? At 6 cases, 540 divided by 6, and so on, right? All right, now there we go. So here we're just looking at the average, basically. Okay. So the quantity of output rises, average total cost first falls, then rises. And again, it's falling because of this, and then we're gonna get to the other reason why average total costs are falling a little bit at first and then start coming back up. Because there's more than just the marginal cost curve that's having that happen, okay? So average total cost curve falls at low levels of output, then rises at higher levels. Some of that is due to worker specialization as you add workers in the very first bit of it at the lower levels of output. But the really important reason that the average total cost curve looks like this, it looks like I said like a bowl, is because of average fixed costs, okay? Fixed costs stay the same. This is another cost curve we're gonna be looking at, average fixed costs. They stay the same regardless of how much output you produce, right? And we looked at that table before that had like from 0 to 12, 10 cases of salsa, and that 108 just stayed the same all the way down, right? As you spread out the fixed costs over larger and larger numbers of output, it's making the average fixed cost become smaller and smaller, okay? So the U shape of the average total cost curve has to do with, at those lower levels of output, costs, total costs are coming down because as you're spreading this out over greater output, the fixed costs, they're getting lower, right? So the average fixed cost curve kind of looks like this. Okay? It just continues to come down. Come down, come down, come down. Okay? Okay. And then what brings this back up again is the average variable cost curve. Okay? And this is when we take our variable costs, mostly labor, okay, and we average it given the quantity of output. Okay, so that's another cost curve. So we've got marginal cost, we've got average total cost curve, we've got average fixed cost, and then above this, what color is left, here we go, is gonna be our average variable cost curve, which looks a lot more like the average total cost curve. It should always be slightly below. And they're gonna mirror one another in terms of like being kind of on the same trajectory, okay? The distance between here and here, by the way, also is equal to the average fixed cost. Okay, the distance between the average total cost curve and the average variable cost curve is equal to the average fixed cost. Are your brains about to explode? Okay, let's take a break right now, and I'd like for you to take a minute to finish up any of your notes, maybe do a little bit of summarizing, and once you finish doing that, go grab a dry erase tablet, a marker, and an eraser from the dry erase board and go back to your desk. So take a minute, walk around, do what you need to, like I said, if you need to take a second to summarize your notes, go ahead and do that.
Yes, please.
Oh yeah, thank you.
Thank you.
Now, eventually, we're going to get to a place where we use these different cost curves to come to some conclusions about how firms are doing within their individual markets. We're not there yet, but the reason you guys need to know this is you need to be evaluating, you need to be able to evaluate for any one firm in a market how they're doing. And their cost curves are gonna give you a lot of that information. We don't have all of it yet, but it's gonna give you a lot of information about how that firm's doing. Should they stay in business? Should they close? Should they invest in additional capital? We're gonna get all to those places later on, okay? In case you were wondering, why do I need to know this? Okay? Okay. Before we move on, there are 4 curves that I showed you, what they look like, how they should be drawn. And what I'd like for you to do is show me on your slate that you can do it, including labeling the axes, in case you missed it, including labeling the axes. Yep. 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 Yep.
For the curve, whenever we're labeling it, we don't have to write all that. We can just write Q.
Q is fine.
Okay.
Yeah. Cool. Good. Yep.
It's so gloomy.
Okay. I'm gonna alter your drawing a little bit once we get a little bit farther. You guys have the basics from what I can see. The one thing I'm gonna add is that the swoosh is gonna cut through the middle, sort of the bottom of the bowl for the average total cost curve. But we're gonna get to that in just a second. I'm gonna show you what it looks like more realistically. What I wanted you to get from this exercise was how are they shaped? Usually kind of what order are they in terms of what's up top, what's below, etc. But it is gonna be changed just a little bit. Okay. One of the things that a firm is trying to do when they are producing whatever it is that they're making, they are trying to maximize their profits and minimize their costs, okay? The ideal level of production for any firm is at the place where they are maximizing their profits, and hopefully that is also at the same place where they are minimizing their costs. Does that make sense to you guys? Yeah, that's gonna make the firm more profitable, hopefully. Okay. So the bottom of the bowl, sort of the bottom of the average total cost curve here, this is the minimum cost level of output. Call it Q sub M. Okay, minimum cost level of output. They've drawn it a slightly different. Okay. At lower levels of output, average total cost falls because of the spreading effect of falling average fixed costs. That is dominating here, as well as some of that specialization that's coming from marginal costs as a result of at lower levels of output, the average variable costs are coming down at first because of specialization, and then they rise because of what's happening with average variable costs. I think I already went over that. So at higher levels of output, the average total costs are rising because they are being pulled primarily by variable costs. Okay. Okay. So, as we've seen, increasing output has the following two opposing effects on average total costs. On the one hand, you got the spreading effect. The higher the level of output, the more you're spreading those average fixed costs out over larger amounts of output. But because of diminishing returns, specifically to labor, in your average variable cost, that's pulling it back up again, okay? So, yeah, this is basically all a bunch of different ways to say the exact same thing, okay? All right,
Ms. Marla, what was the other effect? Spreading effect and what?
diminishing returns. The diminishing returns effect. Right, because at greater levels of output, you need to keep adding more variable inputs, you know what I mean? And you get less increase in that output when you add a worker versus at lower levels of output. Okay. Okay. This is a much more realistic picture of what Salinas salsa cost curves look like. So I had marginal cost kind of up here. You will usually see like the sort of the, not the tail, the head of the Nike swoosh start here and then come up like that. So forget about this. I wish these markers actually worked. It would be here. Does that make sense? Okay. So these are the four curves. Like I said, you're gonna be drawing them a lot. Okay. Minimum cost output. The quantity of output where average total cost is the lowest. It corresponds to the bottom of the U-shaped average total cost curve. At this place, at the minimum cost output, average total cost equals marginal cost. Okay, so remember how I said it was going to cut through the bottom of the bowl? In a realistic scenario, the marginal cost curve is going to look like this. So it's going to cut through the bottom of this bowl. This is the place where marginal cost and average total cost are equal. And that's because this is pulling this down until here, and then the marginal cost curve is now pulling that back up. Okay? Right, so the marginal is kind of pulling it down at first, and then it's pulling it back up. So that's where you get that shape. Okay. This is a way of breaking it down for you, why it looks this way, etc. And I'm not going to belabor all this because we've talked about it already. And then we have a more realistic marginal cost curve with a swoosh shape, as I said. Yeah, at a very low output level, the marginal cost often falls as the firm increases output. And again, that's because people are learning to specialize. Okay, so that at first will cause increasing returns to labor, but it doesn't last long. It's just the first few workers, and then diminishing returns set in, and then you get the upward sloping marginal cost curve. And then the average variable cost curve is now U-shaped like the average total cost curve, and as I said before, it's kind of like right underneath. You'll often see it to be parallel or slightly parallel to the average total cost curve. Okay. This is just a look at how the marginal product curve and the average product curve are mirror images of the cost curves that correspond to them. Okay, so this is just basically saying, like, if this is the marginal product and here's average product, remember those are taken from total product, right? If you flip these around, these are your costs. So this has to do with the inputs and how much output you can get. This is more about what is that cost for the firm per unit of output that they can make. Okay. So this is okay. So this is just looking at, like, well, what could change these costs, okay? If rent increases and that doubles her fixed cost, it will not just shift the average fixed cost curve up by the amount of the rate of increase in rent, it will also shift up the average total cost curve, right? Because the average total cost curve is is also reflecting what's in average fixed costs. This is important. A change in fixed cost will only affect average total cost and average fixed cost. It will not have any impact at all on marginal costs, and it will not have any impact at all on average variable costs. But you guys need to see something. Go back. You good? Okay. That being said, if one of the variable inputs becomes more expensive, that is going to increase marginal costs, which also is going to increase average total costs, okay? So marginal costs are going to increase primarily because of changes in variable costs. So a change in a variable cost will affect the marginal cost curve, the average total cost curve, and the average variable cost curve. Okay. We still have some time left, and I want you guys to try to work this problem. You can do it on your, I want you to draw the graph on your dry erase tablet. You're going to want to use the graph side of it because you're going to have to count some units based on the schedule.